These are your notes for Unit 9, Day 6 of Algebra 1. If you would like to see the warm-up, review question, or any homework questions we covered in class today, just look at the finished notes. So today we are going to continue looking at right triangles, but this time we are going to, instead of using the Pythagorean theorem only, we're going to use something else called trigonometry. And so we're going to use the trigonometric ratios, sine, cosine, and tangent to find the missing parts of right triangles. And then we're going to use those ideas to look at some real world problems. So the ratios in the right triangle, so our trig ratios. So when we did the Pythagorean theorem, we had a squared plus b squared equals c squared. So we're going to continue to keep the Pythagorean theorem as part of our problem-solving strategy. But now notice we also have angles involved. So we have angle A, angle B, and angle C. Well, the ratio of the sides in any right triangle stay consistent based on certain angles. So for instance, if we look at angle A, I can label the sides in relationship to that angle A. So let's just say that that angle down here is x degrees. We know that across from angle A, we have side A, and we call that the opposite side because it's opposite of angle A. It's across from angle A. Well, C always has the same name. We always call C the hypotenuse. So the side across from the 90-degree angle is always going to be called the hypotenuse. The other side that's also connected to angle A, but it's not the hypotenuse, we call that side the adjacent side. It's next to angle A, but it's not the hypotenuse. So we call that the adjacent side. Well, now we can do ratios of the sides, meaning we could make fractions of the sides. So we could do the opposite side divided by the hypotenuse. We could do the adjacent side divided by the hypotenuse. We could do the opposite side divided by the adjacent side, and we would get fractions. Those fractions are our trig ratios. So we have a little mnemonic device to help us remember which trig ratio or which sides go with which trig ratio. And we call that mnemonic device SO, CA, TOA. So we have three trig ratios. We have sine, well, there's actually six, but the three that we're going to look at for Algebra 1 are going to be sine, cosine, and tangent. So those are going to be the three trig ratios that we're going to focus on today. We abbreviate sine, S-I-N, but we still read it as sine. So the sine of angle X is going to be equal to, so this goes with the SO. Well, notice we have O over H. Well, the O goes with opposite and the H goes with hypotenuse. So the sine of angle X is going to equal the opposite side divided by the hypotenuse. So the sine of an angle is equal to the opposite side divided by the hypotenuse. The cosine of an angle, we abbreviate COS, but we still read it as cosine. So the cosine of angle X, cosine goes with A and H. So it goes with the adjacent and the hypotenuse. So the cosine of an angle is going to equal the adjacent side divided by the hypotenuse. And that is your ratio for cosine. It's the adjacent side divided by the hypotenuse. Tangent, we abbreviate TAN, and the tangent of angle X, notice tangent is TOA, so it goes with O and A, so it goes with the opposite and the adjacent. So the tangent of an angle is equal to the opposite side divided by the adjacent side. And that would be tangents ratio. So we have SO, CA, TOA. So sine of an angle is equal to the opposite side divided by the hypotenuse. The cosine of an angle is equal to the adjacent side divided by the hypotenuse. And then TOA, the tangent of an angle, is equal to the opposite side divided by the adjacent side, TOA. So in our angle down here, the sine of angle X is going to equal the opposite side. Well, the opposite side is A divided by the hypotenuse. The hypotenuse is C. So the sine of angle X is going to be A divided by C. The cosine of angle x, well, cosine is ca, it's adjacent over hypotenuse, so it's going to be side B divided by side C. It's the hypotenuse. The tangent of angle x is going to be the opposite over the adjacent, so it'll be A over B. So what if I wanted to do not angle A? What if I wanted to do angle B up here? So let's look at angle B, and we'll call that y. So we'll say that that's y degrees. Well, notice the opposite side is going to be across from angle y. So this side down here is now, instead of the adjacent side, side B is going to be opposite because it's opposite angle y. The hypotenuse stays the hypotenuse because it's still across from the 90. And then side A is adjacent to angle y. So now this side is going to be the adjacent. So now if I'm looking at y instead, the sine of angle y is going to equal the opposite side divided by the hypotenuse. So it'll be B over C. The cosine of angle y is the adjacent side over the hypotenuse. So it'll be side A over C. And the tangent of angle y is the opposite side over the adjacent side. So it'll be B over A. So when you are doing your trig ratios, the very first thing you want to do is you're going to want to circle the angle. So circle whatever angle they're talking about. And then step 2 is you're going to label the sides. So label them opposite, hypotenuse, and adjacent. So when you are doing these problems, your first step is you're going to want to circle whatever angle they're talking about and then label the sides. So let's look at this. So for angle A, we want to find the sine, cosine, and tangent. So first step, circle your angle. So we want angle A, and now we're going to label the sides. Well, across from angle A is the opposite. So 3 is going to be the opposite. Across from the 90 is the hypotenuse. So 5 is going to be a hypotenuse. And then connected to angle A, but not the hypotenuse, is the adjacent side. So 4 is going to be the adjacent side. So remember, we have so, ka, toa. So the sine of angle A, so sine of A is going to equal opposite over hypotenuse. Well, the opposite side is 3, and the hypotenuse is 5. So the sine of angle A is going to equal 3 over 5. The cosine of angle A, well, cosine is adjacent over hypotenuse. The adjacent side is 4, so it'll be 4 over the hypotenuse. The hypotenuse is 5. So the cosine of angle A is going to equal 4 over 5. And then the tangent of angle A, tangent is toa, so it's opposite over adjacent, so it'll be 3 over 4. And that would be the sine, cosine, and tangent for angle A. What if we wanted to do it for angle B? Well, for angle B then, we're going to relabel the sides. So let's erase what we had. And now remember the 2 steps you need to do first is you're going to circle the angle. So I'll circle angle B because that's what we want, and then label the sides. 4 is opposite angle B. 5 is still the hypotenuse because it's across from the 90. And then 3 is next to angle B, so we call it the adjacent side. So the sine of angle B is going to be opposite over hypotenuse, so it's going to be 4 over 5. The cosine of angle B is going to be adjacent over hypotenuse, so it'd be 3 over 5. And then the tangent of angle B is going to be opposite over adjacent, so it'd be 4 over 3. And that would be the sine, cosine, and tangent for angle B. All right, let's look at another one. Find the sine, cosine, and tangent of A. So let's circle the angle that they want and then label the sides. Across from it is called the opposite. Across from C, across from the 90 is the hypotenuse. And then the other side is called the adjacent. Well, notice this time we don't know the hypotenuse, but we know how to find it. We can use the Pythagorean theorem. So we'll label this side C. So A squared plus B squared equals C squared. So 4 squared plus 7 squared equals C squared. So 16 plus 49 equals C squared. So 65 equals C squared. So the square root of 65 is going to be the hypotenuse. All right, so now we want to find the sine, cosine, and tangent of A. Well, the sine of angle A, remember it's so, ka, SOHCAHTOA. The sine is the opposite side divided by the hypotenuse. Well, the opposite side is 7, and the hypotenuse is the square root of 65. So it's 7 over square root 65. To rationalize the denominator, multiply the top and the bottom by the square root of 65. So you would get 7 square root 65 over 65. The cosine of angle A would be adjacent over hypotenuse. So it would be 4 over square root 65. And then rationalize the denominator. So multiply by square root 65, multiply by square root 65. And we would get 4 square root 65 over 65. And then the tangent of angle A is going to equal the opposite over the adjacent. So it would equal 7 over 4. And those would be the 3 trig ratios for angle A. All right, why don't you guys pause the video and find the 3 trig ratios for angle F. All right, first step, circle the angle, label your sides. 4 would be the opposite. The missing side's the hypotenuse, and then 6 feet would be the adjacent. So let's find the hypotenuse, so we'll find C. So 6 squared plus 4 squared equals C squared. So 36 plus 16 equals C squared. So 52 equals C squared. So we get the square root of 52 equals C, which would be 4 times 13. So C is going to equal 2 square root 13. So this side is going to be 2 square root 13. All right. And so the sine of angle F is going to equal the opposite over the hypotenuse. So remember SOHCAHTOA, opposite over hypotenuse. So it'll be 4 over 2 square root 13. I am going to reduce that to 2 over square root 13 because 4 over 2 would reduce to 2. And then rationalize. So multiply by square root 13, multiply by square root 13. And we would have 2 square root 13 over 13. The cosine of angle F would be the adjacent side over the hypotenuse, so it would be 6 over 2 root 13. And so we can simplify this to 3 over root 13 and then rationalize. So multiply top and bottom by square root 13 and square root 13. And so we would have 3 square root 13 over 13. And then the tangent of angle F is opposite over adjacent, so it would be 4 over 6, which would reduce to 2/3. So how do we use these ideas to find the missing parts of right triangles? So what's missing in this right triangle? Well, we're missing x. We can call this side y. And then we're also missing this angle up here, which we could call z. Do you guys remember what the 3 angles of a triangle add up to? The triangle sum theorem? We talked about this earlier in the year. The 3 angles in a triangle have to add up to 180 degrees. So the 3 angles sum to 180 degrees. So we need to take z plus that right angle, so 90 degrees, plus 53 degrees should equal 180. So 90 plus 53 is 143. So 143 plus z equals 180. Then subtract the 143 from both sides. And we get angle z is going to equal 37. So 37 degrees. So this missing angle up here is 37 degrees. Okay, well now we need to find x and y. We can't use the Pythagorean theorem because I don't know x and I don't know y, but we can use our trig ratios and our calculator. So let's circle the angle. I'm going to circle this angle down here, and that's going to be 53 degrees. And now I'm going to label my sides. X would be the opposite side. 15 would be the hypotenuse because it's across from the 90. And so y would be my adjacent side. So now let's do our trig ratios. The sine of 53 degrees equals the opposite side over the hypotenuse. It's going to equal x over 15. Let's do the cosine. The cosine of 53 degrees is going to equal the adjacent side over the hypotenuse, so it would be y over 15. And notice, now I have 2 equations, and one only has x in it, and one only has y in it. So now I want to solve each of those, one for x and one for y. Let's solve this equation right here for x. How do I get the x by itself? Well, right now it says x divided by 15. So to get rid of dividing by 15, we're going to multiply both sides by 15. So now I have 15 times the sine of 53 degrees is equal to x. Okay, well now we can use our calculator. You just need to make sure your calculator is in degrees. So if you have a graphing calculator, which some of you do, you're going to hit the mode button, and then you want to make sure that degrees is highlighted. If you have a scientific calculator, you might need to hit setup or mode if you have that button and select degrees. But on a lot of scientific calculator, you just have a degrees radians button. So it might say DEG somewhere on your calculator, or it might say DEG RAD. You want to make sure that when you do that, the DEG shows up on your screen. So you want to make sure degrees is selected. On Desmos, so if we wanted to do this on Desmos, you just hit that little wrench button up in the corner, and then make sure, so at the very bottom it says degrees and radians, select degrees. So you want to make sure degrees is the one that is filled in green. So notice radians is, now degrees is, make sure degrees is filled in. So you just hit that little wrench up in the corner. And so now I'm going to take 15, and to get to the sine button, you hit the functions button. So that little gray button right there that says functions. And then notice the first one says trig, and that very first button is sine. So you're going to hit 15, then sine, and then 53 degrees. And so that side x is going to equal 11.979. So we'll call this 11.98 is going to be the length of that side. So the length of that missing side is going to be 11.98. On some of your calculators, you might have to hit 53 and then the sine button, but I think on most calculators, you'll hit the sine button and then 53. So mess around with that. And to make sure you have it right, the sine of 53, you should get 0.7986. So when you're doing that on your calculator, to make sure you have the right mode selected, you should get 0.7986 as the sine of 53 degrees. And then if you multiply that by 15, notice you get the 11.98 for that side length. All right. The next one says the cosine of 53 degrees equals y divided by 15. Well, to solve for y, again, we're going to multiply both sides by 15. And so it's going to be 15 times the cosine of 53 degrees equals y. So now same thing. This time we're going to select the cosine button. So we're going to do 15 times the cosine of 53 degrees. So cosine's the second button, and then 53. And we get y is equal to 9.027. So we'll just do 9.03 is equal to y. So that missing side is going to be 9.03. So x is going to be 11.98, and y is going to be 9.03. And those are approximations because I rounded them, but those would be my missing two sides. All right, let's look at two other examples. So in that first one, we have the 26 degrees. So we are missing this side. Again, I'll call it y, and we're missing that angle, so I'll call it z. The three angles need to have to add up to 180. So 26 degrees plus 90 degrees plus z degrees is going to equal 180 degrees. 90 and 26 make 116. So 116 plus z equals 180 degrees. So subtract the 116 from both sides, and you get 64. So angle Z is going to be 64 degrees. So that angle is 64 degrees. And now to find the missing sides, we're going to circle an angle and label the sides. So we'll circle 26. Y is the opposite. X is the hypotenuse. And then 15 would be the adjacent. And so now we have the sine of 26 equals opposite over hypotenuse, so y over x. Notice I can't use that one because we are missing two sides, so it has two variables in it, so I can't use the sine equation. The cosine of 26 is going to equal the adjacent side over the hypotenuse, so it'd be 15 over x. Notice that one was only missing x, so we're good. We can use that equation. And then the tangent equation, the tangent of 26 is going to equal the opposite side over the adjacent, so it would be y over 15. All right, let's solve the cosine equation first. Well, notice what I'm trying to solve for is in the denominator. So to get x out of the denominator, we're going to multiply both sides by x. So now I have x times the cosine of 26 degrees equals 15. Well, I want to solve for x now, so I'm going to divide, because it's x times something, so I'm going to divide both sides by the cosine of 26. So x is going to equal 15 divided by the cosine of 26. Well, let's do that. 15 divided by the cosine of 26 degrees, and we get 16.689. So we'll take 16.69. So that missing side is 16.69. And then to find y, tangent 26 equals y divided by 15. So let's multiply both sides by 15. And so 15 times the tangent of 26 degrees is going to equal y. So 15 times the tangent of 26 degrees. And so y, that missing side, is going to be 7.32 if I round. All right, why don't you guys pause the video and try the second triangle? So try and find all of the missing parts of that triangle. All right, so we're missing the hypotenuse, so I'm going to call that side y. And then we're missing that angle, so I'll call that angle z. And so we know that 90 plus 48 plus angle z equals 180, because the three angles need to add up to 180. So 138 plus angle z equals 180. Subtract the 138 from both sides. And so angle z is going to equal 42. So that missing angle is 42 degrees. Circle the angle, label the sides. So x is the opposite, y is the hypotenuse, 17 is the adjacent. So the sine of 48 degrees equals opposite over hypotenuse, so x over y. I can't use that because I have two variables. The cosine of 48 is going to equal the adjacent side over the hypotenuse, so 17 over y. And then the tangent of 48 is going to equal the opposite over the adjacent, so x over 17. All right, to solve this one, get y out of the denominator, so multiply by y on both sides. So y times the cosine of 48 equals 17, and then divide both sides by cosine 48. So y is going to equal 17 divided by cosine 48. Oops. 17 divided by cosine 48. And you get that side is going to be 25.4. So side y is going to be 25.4. And then on this one, to solve for x, we're going to multiply both sides by 17. So 17 times the tangent of 48 equals x. So 17 times the tangent of 48 is going to be 18.88. So that missing side is going to be 18.88. All right, you guys pause the video and try these two. You can check your work against the finished notes from class today when you're done. All right, well, what if you don't know any angle other than the right angle? So what if we're trying to find a missing angle and we can't use the triangle sum theorem? So let's call this angle A. So again, first step, circle the angle, label your side. So this side is the opposite, this side's the adjacent, this side's the hypotenuse. Well, which two sides do I know? I know the adjacent and hypotenuse. Which trig ratio involves the adjacent side and the hypotenuse? The cosine does. The cosine of angle A is equal to the adjacent side divided by the hypotenuse. Well, I need to solve for A, and right now I have cosine A. Well, you can undo or take the inverse of cosine. The inverse of cosine is a button on your calculator, and it looks like this. So that cosine that has that little -1 up above it, we call that inverse cosine. So how we say that out loud is inverse cosine. So if I take the inverse cosine of cosine A, the inverse cosine and cosine cancel, and I'll just be left with A. But whatever you do to one side of the equation, you have to do to the other side. So I'm going to take the inverse cosine of 19 over 26. To do this on your calculators, for a lot of you guys, you're going to have to hit second and then the cosine button, or you might have to hit shift and then the cosine button. So hit second or shift and then the cosine button, and you'll get the inverse cosine button. On Desmos, we're just going to do the inverse cosine, so it looks like that, and then we're going to do 19 divided by 26. And that's going to give me what angle A is. So angle A is going to be 43 degrees, and I'm just going to round to the nearest angle. So that's going to be angle A. Once you know angle A, then you can use the triangle sum theorem to find any other missing angles. So again, to find a missing angle in a right triangle, if you can't use the triangle sum theorem, you're going to use the inverse sine, inverse cosine, or inverse tangent buttons on your calculator. So let's look at another one. So how would I find that missing angle? Well, again, we'll call this angle B this time. And so label the sides. 17 is the opposite, 43 is the hypotenuse, and then this side was D, the adjacent. What two sides do we know about? We know about the opposite, and we know about the hypotenuse. Which trig ratio goes with opposite and hypotenuse? Sine does. So the sine of my missing angle, and we called that B, equals the opposite side 17 divided by the hypotenuse 43. Again, I have sine B, but I just want to know what angle B is. So to find angle B, we're going to take the inverse sine of both sides. So we're going to take the inverse sine of sine B and the inverse sine of 17 over 43. Inverse sine and sine will cancel. So then I'll just have angle B. And now we're going to take the inverse sine. So inverse sine, you might have to hit shift or second sine. And then we're going to do 17 divided by 43. And so angle B is going to be 23. And then we'll round that to 3. So 23.3 degrees. All right, so let's use that idea to solve a right triangle. Well, this is this is very similar to the ones we've already done. So you guys can pause this video and try this one because you can use the triangle sum theorem on this one. All right, angles of elevation and depression. So we use these ideas in order to solve some real world examples. So for instance, if you had a tree and you were looking up from the ground, so this is you and you're like laying on the ground, and you're looking up at the tree, that's called an angle of elevation. So this angle right here is called the angle of elevation because you're looking up at the tree. If you were in a building and you were on the top of the building and you were looking down at the tree, then your angle of depression is going to be right here. So you make a different triangle. And this angle right here is going to be your angle of depression because you are looking down at the tree. So angles of elevation are looking up at the tree, so they'd be in that bottom quarter. Angles of depression are looking down, so you would draw that rectangle and they would be looking down. So a sonar operator on a cruiser detects a submarine at a distance of 500 meters and an angle of depression of 37. How deep is the submarine? So we want to know how deep is the submarine. So we can call that side X. Well, again, circle your angle, label your sides. So X is the opposite, 500 is the hypotenuse, and this side up here is the adjacent. Which two sides? 500, and I want to know X. So I have the hypotenuse, I want to know the opposite. Who goes with opposite and hypotenuse? It's the sine. So the sine of 37 degrees is going to equal the opposite side divided by the hypotenuse. So X over 500. We're trying to solve for X. So we're going to get rid of the 500. So multiply both sides by 500. And so 500 times the sine of 37 is going to equal X. All right, so let's do that. So 500 times the sine of 37. And so the depth of that submarine is going to be 300.9. And then what units are we in? It's going to be meters. So that submarine is 300.9 meters deep. All right, let's look at another one. A golfer is standing at the tee looking up to a green on a hill. if the T is 36 yards lower than the green, and the angle of elevation from the T to the hole is 12 degrees, find the distance from the T to the hole. So what are we trying to find? We're trying to find this distance right here. So from the T to the hole. So there's the hole, and here's the T. We want to find that distance, so we'll call that X. So we're trying to find X. So again, this angle down here is 12. They put it pretty far up. So circle your angle, label your sides. So this would be opposite. Across from the 90, across from the 90 is the hypotenuse, and then this side's the adjacent. So we know the opposite side. We're trying to find the hypotenuse. Which trig ratio goes with opposite and hypotenuse? That would be sine. So the sine of angle 12 equals the opposite side divided by the hypotenuse. So sine 12 equals 36 over x. We're trying to solve for x, so we need to get it out of the denominator. To get it out of the denominator, multiply both sides by x. So I have x times the sine of 12 degrees equals 36. And then to solve for x, we're going to divide both sides by sine 12. And so x is going to equal 36 divided by the sine of 12 degrees. So 36 divided by the sine of 12 degrees. And we get the distance to the pin is going to be 173.15 yards. So that is the distance from the pin to the hole. All right, your homework is from 9.7. Let me know if you have any questions.